Derivatives of trigonometric functions are a little bit trickier to find, and it's one of those things where you just really need to understand a couple of concepts involving sine of x and cosine of x. And once you understand what those concepts are, you can really find the derivative of any trig function at that point. So I'm going to show you how to visualize the concept of the derivative of sine of x is cosine of x, but why? Why is cosine of x the derivative of sine of x? Here's a really cool way to understand why that is. We know that a derivative is simply the equation that gives us the slope of a line tangent to any point on a function, any one single point. So let's think about the slopes of lines tangent to any point on the sine of x function. So I'm just going to plot a couple of points here. And the only thing I want to show you, I don't want to talk about the actual numerical value of the slope. I just want to talk about the positive or negative nature of the slope of a line tangent to these points. Let's start with this point here. If I were to draw a line tangent to this point, you'll see that the slope is positive. It's sloping in a positive direction, right? And how about this point here? The slope of a line here, also positive, right? This point, also positive. But what do you notice is happening here? As I go up this side of the sine of x function, the slopes of my tangent lines become less and less positive. The gradient of this line is starting to orient towards a horizontal orientation until I finally get to this point here, right up here at the top, where if I were to draw the tangent line here, you'd see that it's horizontal, which means that the slope is 0. So it starts out positive, becomes less and less positive until it finally reaches 0. Okay? Now as we go down this side of the sine of x function, I'll plot a couple of points here, you're going to notice that the lines tangent to these points all have negative slopes, right? Here's a negative slope. And what starts to happen is the slopes actually become more and more negative. They are sloping in a more and more negative orientation. The numerical values of these slopes are actually further away from 0. Their absolute values will be further away from 0 until we hit about this point here, which is the x-axis. And then if I start plotting a couple of points on this portion of the sine function, you're going to notice that lines tangent, their slopes remain negative, but they are starting to become less and less negative. Okay, so there's this turning point here. Positive, starts out positive, becomes less and less positive. We're talking about the slopes of lines tangent to points on this sine function until they finally reach 0, and then they take a turning point into the negative spectrum, and they become more and more negative until they reach the horizontal axis. The slopes remain negative, but they start to become less and less negative until we reach this point here where the slope of this line tangent is horizontal or 0. And at that point, another turning point happens, and you're going to see that the slopes of lines tangent to points on this portion of the sine function are back to being positive, and that they become more and more positive until they reach about here, which, can you guess, probably going to take another turning point, right? So let's kind of recap what happened here with the slopes of lines tangent to points on the sine function throughout this entire period. We start out here where the slopes become less positive as you go up this side of the sine function until they hit 0. Then on this side of the sine function, the slopes become more negative until they reach this point here, which is at the horizontal axis, right? Now notice the slopes don't become 0, they just simply change direction and start to become less negative at that point, right here. And then they continue to be less negative until we reach this point here where the slope is 0 again. And then another turning point happens where as we go up this side of the sine function, the slopes now become more positive. Okay, and when I say less positive, more negative, less negative, more positive, what I mean is their absolute values are either going further and further away from zero or becoming closer and closer to zero, right? So let's go ahead and take just the positive or negative natures of these slopes and graph them on a new graph. The second graph I have down here, okay, I'm just going to graph just the positive or negative natures of these slopes. So we know here's our horizontal axis, right? Here's our horizontal axis. Anything above the horizontal axis is going to be positive, and anything below it is going to be negative. And I'm just going to graph these slopes here. Okay, we start out with positive slopes that start to become less positive as they approach zero. So we are going to start out with positive slopes that become less positive as they begin to approach zero. And then here at this point on the horizontal axis is when they hit zero, right? And then at that point where they hit zero, they start to become more and more negative, meaning that we're getting further and further away from zero. So they become more and more negative. Just plotting a couple of, remember these dots are representing the slopes of lines tangent to the sine of x function as we go through one period of sine of x. So they start out positive, become less and less positive until they hit zero, and then they become more and more negative, going further away from zero until they hit a turning point. Here's this turning point here, right? And then they start to become less and less negative. So here's the turning point where they become less and less negative. So now we're going to get closer and closer to zero until, boom, we hit zero again. Less and less negative until we hit zero. And then there's another turning point that happens at zero where they start to become more and more positive. So now our numbers are going away from zero in the positive direction, right? And then we can assume that this pattern happens over and over and over throughout each period of sine. So here, this side is the side of sine of x where the slopes became less positive. Here's the side of sine of x where the slopes became more negative. Okay, so we're just following the pattern here, less positive, more negative, less positive, more negative. Here's the turning point, another turning point here. Here, actually, right here at the horizontal axis is where the slope was zero. Okay, right here. Then it became more negative. Then there was the turning point here where the slope started to become less negative. So up, less negative. And then we hit zero here. Here's where the slope was zero, and then the slope started to become more positive. Okay, now if I were to draw a line connecting the dots here, you're going to notice something that happens. This looks like a cosine function. If I connect all of the dots representing simply the slopes of lines tangent to the sine of x function, it looks like a cosine function. And this is your visual representation of the derivative of sine of x being cosine of x. Okay?